Hey guys, thanks for coming back again to watch, think, learn. I don't know what learn means actually, but maybe we'll see more examples of this stuff I call dimensional analysis or unit conversion, changing one measured quantity into a different unit. You know what units are, right? Like units of length, units of mass, units of volume, units of energy. Um, the idea is this. It's a simple idea, but it can be very complicated. It involves some measure of creativity and practice. If 1 inch equals 2.54 centimeters, that's I think that's a definition. I'm not sure. 1 inch exactly is 2.54. I think that's an exact. I'd have to look it up. What I can do is I can put 1 inch on top and 2.54 on bottom, or vice versa. I can flip it upside down. You say, well, why would you want to do such a thing? Because if I had some measure of length in inches or in centimeters, I could multiply by this factor, which is a factor of 1, and I don't really change my original measurement. That sounds pretty weird. And that applies to any equality. If, indeed, 8 pints is 1 gallon, I can write it like this or upside down. I'd write it like this if I wanted to multiply. I'll shut up. Let me just I apologize. Let me give you some more examples and then show you how it's used. Or pounds and grams, miles and kilometers. And you don't have to know any of these conversions really of weird metric to English or bizarre units. It's good to know the basic milliliter, milli-unit, and the centi unit and the kilo unit, or prefixes I should say, but other than that, you don't have to know what an angstrom is. You don't have to know what a picometer is. You don't have to know that there are 0.62137 miles in 1 kilometer. 1,000 milliliters in a liter. Yeah, you should know that one. And you should know this one too. 1 milliliter is a cubic centimeter. This one, that's very obscure. And this one's also pretty obscure. If I was measuring the mass of one atom or even one proton, I might use this very, very small unit of mass called the atomic mass unit. I had to look this up. I don't have this memorized. That's crazy. But I can write it like this or like this. Also with time, 1 hour, 60 minutes, 1 minute, and 60 seconds. Why'd I put that there? Liters and quarts. All right, let's get down to business here. Let's do some conversions. I call it also the factor of label method sometimes. It's used to convert one quantity into another. We're changing units from one to the other. Many years ago, a scientist for NASA forgot to convert metric to English or something, and he ended up crashing a multi-million-dollar Mars probe. I'm sure he lost his job. Anyways, for this first number I always just make up, 43.7 minutes. How many seconds is that? Well, almost always we put the minutes on the bottom, so the minutes here cancel with the minutes here, and I have 1 minute equal to 60 seconds. So this is it. Basically, this one, 60 seconds over a minute, is basically unity, right? It's just 1. But this times 1 is still the same thing, but it's changed its clothing or changed its units. And so 20 seconds is equal to 43.7 minutes. Yeah. If I asked you how many seconds were in 2 minutes, you could easily do that in your head. But if the numbers get messy, then I prefer to write it out in a formal way like this. Also, I'm trying to pay attention to sig figs. It is true that 1 minute is exactly 60 seconds, so this conversion factor doesn't limit my number of sig figs. But if I had 3 sig figs here, my final answer should be rounded to 3 sig figs. That last zero doesn't count as significant. It's in back of a big number locating the decimal, and I'm claiming that it's not really measured or certain at all. As a matter of fact, that too is a little bit uncertain. Maybe it's 263 or 261 seconds based on this, and that 7 is not exactly certain either. Maybe that's really 43.6 or 43.8. I'm not quite so sure if that's long story. 3 sig figs here. 1 mile is equal to 5280 feet. Don't remember that, but I'm just saying I put the feet on the bottom. So this foot cancels with that foot. And in a sense, I'm treating these units as algebraic quantities when I cancel them out. And you can do that. This gives me a huge irrational number. These zeros in front don't count as significant. Just locating the decimal for this 327 yada yada. But if this has 3 sig figs, then I'm going to round this off to 3 sig figs. And that is also written as 3.28 times 10 to the negative 4 miles. Although that's in scientific notation, right? What if I wanted to convert weeks into seconds? Well, for example, here's how I'd go about it. 2.63 weeks. Is it true that 1 week has exactly 7 days? Is it true that 1 day has exactly 24 hours? Is it true that 1 hour is 60 minutes? Is it true that 1 minute is 60 seconds? And my weeks cancel, and my days cancel, and my hours cancel, and my minutes cancel. And the math goes 2.61 times 7 times 24 times 60 times 60 divided by 1's in the bottom, so I can basically ignore the denominator. Excuse me. And I get my final answer. Let's see, this 2.61 had 3 sig figs, so I need to round this off to 3 sig figs. I could write it like this, but it's probably more common to see it in scientific notation. 3 sig figs. Those zeros wouldn't count as significant if I just wrote it like that. But like I said, it's more common to write it in scientific notation. Alright. This is such a weird format, right? I'm talking to a computer screen, but I'm really talking to you, the student. So it's weird for me to talk to a computer screen, thinking about who I'm talking to, wishing that you could ask a question. But alas, here's a tricky one. What if I want to convert miles per gallon? My car gets 36 miles per gallon, if it's a, an efficient car, into kilometers per liters. So I change the miles by putting miles on the bottom, kilometers on the top. Then I convert gallons by putting a gallon on the top, and it's a conversion to liters on the bottom. So 3.7854 liters is 1 gallon. That's probably exactly 1 gallon. That's exactly 1 mile. Sometimes these exact quantities don't limit our sig figs. So here I have 2 sig figs with 36. I'm pretty sure in the end I'll have 2 sig figs with my answer. But in any case, you see my miles cancel and my gallons cancel. In this example, I put the gallons on the top because I wanted to cancel these gallons on the bottom. And now I have liters on the bottom, and that's what I wanted. I wanted kilometers in distance per liter's volume. Your car gets this many miles, travels this many miles per liter of gasoline. And so the math is 36 times 1.6093 times 1 divided by 1 and also divided by 3.7854. Be careful of the order of operations on your calculator. Sometimes this is easy to screw up. Yeah. Here's another silly one. Converting miles to kilometers. This has 2 sig figs. Those zeros don't count as significant if I'm not mentioning the decimal. And maybe I'm not appropriate in mentioning the decimal. Maybe I only measure the 2 and the 5, and that 5 might be a bit of an estimate anyway. So even if my conversion factor has lots of precision, my answer must be rounded to 2 sig figs, and the best way to write that is 2 sig figs. The scientific notation doesn't count for or against sig figs. Oh yeah, right, there's another sig fig video, isn't there? So if you haven't watched the video on sig figs yet, this might make a little more sense when you go watch that. But in any case, these are tricky. What if I want to convert areas or volumes? Areas is like a surface area, and a volume is like a three-dimensional space. Well, for one thing, if I go length times width times height, I got to be careful about my units and make sure they all match up. It'd be nice to have them all in centimeters, because a cubic centimeter is the same as a milliliter. So that decimeter is not going to fly, and that meters isn't going to work unless I change this one. So I got to convert all 2 of them to the others. So I'm going to convert this to centimeters and that to centimeters. I wouldn't blame you if you didn't remember what a decimeter was, but it's like, what is it? A decimeter is 1/10 of a meter, and a centimeter is 100th of a meter. So that's why I got 21 decimeters in 21 centimeters and 2.1 decimeters. Anyways, 100 centimeters times 21 centimeters times 5.6 centimeters gives me an answer. I'm not going to round to the very end. I leave all those digits for now, and I take them over here and say 1 inch is equal to 2.54 centimeters. So if I had a cube that's 2.54 by 2.54 by 2.54 centimeters, that's also called an inch by an inch by an inch. But in this case, I'm cubing this number and cubing the unit, and I'm cubing this number and cubing the unit, cubing the bottom and cubing the top. This is an equivalence, but if I do this, if I cube the bottom to get rid of that, I have to cube the top. Well, 1 cubed is still 1, and an inch cubed is an inch cubed. That unit survives. But a cubic centimeter here cancels this cubic centimeter, but I can't forget to cube that 2.54. So 2.54 times 2.54 times 2.54, take that number, divide it into 11,760, and I get an irrational number. But since my original This had 2 sig figs, this has 2 sig figs, this has 2 sig figs, so I rounded my answer to 2 sig figs. Here's a science fiction-y example. Kind of silly, but it's true. Too bad we can't travel faster than the speed of light, really. Interesting idea, though. Let's say a warp factor 2 in the USS Enterprise or whatever. That 5 times the speed of light is 1.71 warp factor. That's a ridiculous science. Who would know that? I wouldn't know. I had to Google that. It's science fiction anyway. But warp factor of 2, 1.71 warp factor is 5 times speed of light. So this warp factor cancels that warp factor. 2 times 5 is 10 divided by 1.71 gives me this number of speed of light units. The speed of light is this speed. That's not science fiction. That's measured. So I could say 1 speed of light equals 3 times 10 to the 8th meters per second. Converts to meters per second. This had 3 sig figs. I rounded my answer here to 3 sig figs. Although maybe, truth be known, I might have, shoulda, coulda, woulda waited to round that till the very end if I was going to continue further. Here I see I took the meters per second and changed them into miles per hour. So the meters go on the bottom and the seconds go on the top. It's true that 1 mile is this many meters. The meters cancel, and my seconds go on the top, 3,600 seconds in 1 hour. Seconds cancel. So 1.754 times 10 to the 9th times 3,600 divided by 1,609.3 gives me this number. And paying attention to sig figs, this said, I rounded here, but then I carried another digit here. Alright, so I didn't round too soon. But if this had 3 sig figs up here in the very beginning, and I don't limit the sig figs with my conversion factors, this should have 3 sig figs. Wow, that's fast. Other interesting applications of unit conversions is like density. I can use a density of 7.8 grams per milliliter to cancel milliliters. So my volume, if I knew the volume of my object that had a density of 7.8 gram per milliliter, I could imagine the milliliters canceling and giving my grams. Or if I had a mass, I could use the density upside down. Whoa, 19.3, that must be mercury. Oh, it's gold, I see. So gold's very dense. So the grams cancel, converting to milliliters. I could say this. Oh, to the -1 means, what does that mean? Oh yeah, that's a reciprocal, or put it on the bottom. So mass divided by density is volume. You got to become comfortable with that, especially in Gen Chem 2, but good to start thinking about it right now as well. Alright. Oh, here's a way of counting particles called the mole. What if I had, now you don't know what a mole is yet, maybe you don't, unless you've ever had chemistry before, you might know. 3.71 moles of hydrogen molecules. This would probably come from a thermochemical equation. So this, you're not seeing where this conversion factor is coming from right now. But if I were probably to burn 2 moles of hydrogen in sufficient amount of oxygen to make water, I would get a release of 281 kilojoules of energy. So my moles cancel, voila, and I'm left with kilojoules. This has 2 sig figs, and around this to 2 sig figs. That 0 doesn't count as significant if I don't mention the decimal. Here's a good example from medicine. A little kid weighs 15 kilograms, 15.1 kilograms is mass, 15.1 kilograms. Is that going to be too big? Yeah, a little bit too big. Shoot. Go back smaller. This kid is sick and he needs some medicine. The dose of the medicine is described as milligrams of medicine per kilogram of body mass. So for every 3 kilograms of body mass, we want to administer 20 milligrams. A milligram is 1/1000th of a gram. So put the kilograms, the kid weighs 15.1 kilograms, but I want, for every 3 kilograms of body mass, I want 20 milligrams of medicine. So voila, round it to 2 sig figs. And it looks like he needs about 100 milligrams, at least 2 sig figs, written like that. Here's another really, this line, this goes on for, here's a weird example. You know what, I'm just going to leave that for you. Who has ever heard of the Apothecarian system of measure? Unless you're 100 and some years old, you probably have not. But that's silly. I'll give it to you. Look at it if you want to. It's a good example, I suppose. Let's apply that idea of unit conversion to a story problem. If a half inch of snow falls across the county, how much does it weigh? What's the mass of snow? You wouldn't think very much, right? Because snow is so light and fluffy. The density of snow, 0.08. Snow would definitely float on water if it didn't melt right away. And there's 5280 feet in a mile, and 1 inch is 2.54 centimeters. Oh yeah, and the surface area of the valley is 764 square miles. Well, if you feel like a genius, pause the video right now and figure that out. Builds character. Be good for you. Just kidding. No, not really. It'd be good practice. But in any case, here's the answer. So I know the valley has an area of 764 square miles. And then I convert the square miles to square feet. 1 mile is this many feet, but I got to square both of them, so the square miles cancel the square feet. Or square miles cancel, convert to square feet. And inches and feet, but I got to square that. And centimeters and inches, but I got to square that. Thinking about area. And so this times this squared, times this squared, times this squared, got ones in the bottom, that's convenient, comes out to a big number of square centimeters. So this is a cartoon of Salt Lake County. Well, okay. And if it's a ½ inch thick snowfall, then I put a half. Maybe, I'm not sure if that's going to lead to problems with sig figs. We could assume it's an exact number, although measuring a ½ inch across the entire valley is not going to be exact, is it? Anyways, let me convert the inches of snowfall into the height or depth of snowfall. And then I'm going to use the depth and the area to figure the volume of snow. So length times width times height gives volume of snow. Gosh, is that too big? It's just barely too big. Well, maybe I'll leave it like that for a second. Length times width times height. There's the length times width times the depth of the snow, the height. Gives me a lot of milliliters. What would that be? That'd be, oh geez, that's like 2 billion liters of snow at that density. So now we can use the density definition, or we could probably use the density as a conversion factor to find the mass of snow. And that looks like, make that smaller again. Oh, hang on a second, guys. This is my last page. Sorry about that. I fixed it. Now we can see the last line here. I could use the density as a conversion factor, or I could do it the old-fashioned way where I say density is mass over volume, so mass is density times volume. So there's the density of the snow originally given, and that's the volume I had to work so hard to figure out with the converting the area of the county into into square centimeters, and then the height of the snow is a half an inch, and convert that to also to centimeters, and then I got the volume. And yeah, so what, 2 sig figs? 3 sig, what? Oh yeah, the original number was like 7. Well, that would have to assume that I had 0.500 to 3 sig figs, inches of snow across the whole valley. That 764 miles, was it, of area of Salt Lake County, that had 3 sig figs as well. So let's assume that was 0.500 inches across the whole valley. Whoa, that's a lot of snow. Very heavy. You know how heavy snow is because you've shoveled it before. Except not in August or September, hopefully. Alright guys, take care. See you in class. Thank you so much for watching.